Hey everybody, I'm going to be helping you with Lesson 11's homework tonight. We're going to see a couple different ways that we can show equivalent fractions using tape diagrams and number lines. So here, what it's saying is label each number line with the fraction shown on the tape diagram. So really we have our tape diagram, which we know is separated into thirds because we can count. But really all we're doing is we're going back and we're labeling it underneath the number line. So here this is 1/3. Okay, let me put my 0 first. We start at 0. That's 1/3, 2/3, and 3/3. So really it's just a number line that goes along with the tape diagram. And I circled 1/3 because it told me to circle the fraction that goes with what's shaded. I'm going to do the same thing down here. When I count, I had 6 boxes. So I'm going to count by 6. So 1 6, 2 6, 3 6, 4 6, 5 6, and 6 6. And of course we start with our 0. And again, I'm going to circle 2 6 because the directions told me to circle the fraction that goes with the number of shaded pieces. Counted down here, and I got 12 pieces, it looks like. So I'm going to start with 1/12, 2/12, 3/12, 4/12, 5/12. And while I do this and go down the line, it's always important to start with 0 because when you start at the beginning of the number line, you haven't gone anywhere yet, so you have to start with 0. Okay, wrapping it up, we're at 11/12 and 12/12. Again, I'm going to circle 4/12 because that's what goes with what is shaded. There's 4 of the 12 boxes shaded. Okay, now we're going to use what we just did to answer some questions. So the question says, write a number sentence using multiplication to show how the number in 1a is equivalent to the number in 1b. Well, let's go back. 1a was 1/3 and 1b was 2 6. So I want to show that they're equivalent using what we've done in the past. So I'm going to write 1/3 is equal to 2 6, and I'm going to use that using multiplication. Now your teacher may have shown you a little bit differently, but I show my kids just to put the tiny times 2 on the numerator, and the denominator, to show that 1 times 2 is 2 and 3 times 2 is 6, so that proves that it's equivalent. That's just a little shortcut that we've been using. Okay, now we're going to compare the two numbers from 1a and 1c. Well, 1a was 1/3, and I just looked back up, and 1c was 4/12. So in order to prove that these are equivalent, if I multiply the top and the bottom number by the numerator and denominator, by the same number, you should get the same thing. So 1 times 4 is 4, and 3 times 4 is 12. Now, if you look back up at all of the other examples, all of the shaded area takes up the same amount of space. They're just separated into smaller pieces, so that also shows it's equivalent. Okay, on this part, you have to draw your own number line. So I'm going to start by making it just as long as the tape diagram, putting the lines where the lines are, and now let's count our pieces. Looks like we have 1, 2, 3, 4 pieces. So that means I'm going to count by fourths. So 1/4, 2/4, 3/4, and 4/4. And I circled 2/4 again because that's where it's shaded. Okay, we're going to do the same thing again on part B. So I'm going to draw my own number line. And now I need to count all the pieces to see what I'm going to count by. Looks like I'm counting by eighths. So I'm going to line up my lines here. I'm going to count by eighths. So start with 0, 1/8, 2/8, 3/8, 4/8, 5/8, and I'm going to circle that 4/8 because it's the shaded part. 5/8, 6/8, 7/8, and 8/8. Okay, and we have one more to do the same thing for. It looks like, if you look at A and B, that they're covering the same amount of space, but we're going to check here in a minute with some division. Okay, so we're going to put our lines that match up. And when I end up counting all the boxes, it looks like we have 10. So I'm going to count by tenths. So I'm going to say 1/10, 2/10, 3/10, 4/10, 5/10. And I'm going to circle that because that's where it's shaded. 6/10, 7/10, 8/10, 9/10, and 10/10. Okay, now is where we're going to compare. So on the next page, it asks you to write a number sentence using division division now, not multiplication, to represent how 3a and 3b are equivalent. Now it's going to be a little bit different because we're not using multiplication, we're using division, but we know that those operations go together, so let's look. Well, 3a is 2/4 and 3b is 4/8. So instead of doing it with multiplication, I'm going to write it with the one that has the larger denominator and numerator first. And instead of saying times 2, if I divided the top and the bottom, the numerator and denominator by the same number, I should get the same effect. So 4 divided by 2 is 2, and 8 divided by 2 is 4. And off to the side, this is what it would look like if I asked you to do it with multiplication. Same effect, just if you're going from the larger numbers, you have to divide instead of multiply. Okay, the next part says partition a number line from 0 to 1 into fourths. So I'm going to draw me a number line. It says fourths, so I'm going to split it in half, and then I'm going to split those halves in halves. Let's see if this works. So 1/4, 2/4, 3/4, and then 4/4 is the same as 1. So I'm going to write that over to the side. So that's where that would be. And then it says decompose 3/4 into 6 equal lengths. Now that sounds kind of weird, but 3/4 is 3 pieces. So if I wanted 6 pieces, then I could split each one of those 3 in half to get 6. So let's try this out. So here's my 3, and if I split each one of them in half, I get 1, 2, 3, 4, 5, 6 equal pieces. Now the next question says to write a number sentence using multiplication to show what fraction represented on the number line is equivalent to the 3/4. Well, I don't even know what those red tick marks are yet, so I need to figure that out. So let's come back up here to the number line, and let's count how many pieces we've separated into if we did the whole thing. So I count 1, 2, 3, 4, 5, 6, 7, 8. It's 6 if you just count the 3/4, but it's 8 total if you were to keep splitting the whole. And I'll show you what this looks like in an area model in a minute if you're confused. So if I were to count, the red mark would be 1/8, 1/4 would be the same as 2/8, 3/8, 4/8 would be the same as 2/4, 5/8, and 6/8 would be where 3/4 is. So you kind of see how in between I have the 8s, and then underneath the 4ths I have what's equivalent in 8s. So really I could see that 3/4 is equivalent to 6/8, and I showed that with 3 times 2 is 6 and 4 times 2 is 8. Now this is a little confusing for some of us because we've been using the area diagram, or the area model. So look here, I had 3/4, and then I split those 4ths into 6, and now, I'm sorry, not 6/8, and I end up with 6/8. And so you can see how it works out the same way. It just depends on what model you prefer using, but you will be seeing both of these on assessment, so you have to know how to use both. Okay, and now they're asking me to do the same, show how 6/8 and 3/4 are equivalent again, but use division. And so really it's the same thing, except now I'm going to say 6 divided by 2 and 8 divided by 2. So if it's going from the bigger denominator to the smaller, we're going to divide. All right, thanks guys. Have a good afternoon.